want to kind of jog our memories a little bit about what we did so long ago now, so that we can all be back in that moment a week ago. I had given you little papers. I had given you stacks of paper. And can you remind me of the story? What was the story that we were telling, or the thing that we were trying to work through? What's that? Trying to build a beach. And what were we building the beach from? Rocks in big air quotes, right? Made of paper. So we had this yellow paper, these stacks of paper that were over at some of the, I saved one for you all to jog your memory. It's super cute. I don't remember if it's from your class or a different class, but anyway. Stacks of paper that were over up high on the mountains, right? And what happened to that paper? It got ripped. Scientific term for that would be? That's what I'm asking. The people that tore the paper, what was that called? What were you doing? You were the weathering people, right? Yeah, so you were weathering, you were tearing it away. Please put your phones away. Thank you so much. And then, did the weathering people get to take the paper over to the beach? No, they didn't have the opportunity to get their steps in that day. Who was that? The erosion people. The erosion people ran back and forth and back and forth. So they were transporting all of that rock, right? And then, who did they take it to? The deposition people, right? And what did the deposition people do? Glued it down, yeah. So hopefully you were able to answer your question there about what part did you play in that. We're going to write down all of them real quick, and then we're going to take some notes on it. We're just going to get this stuck, cemented in our heads, if you will. You're welcome for that. All right, here we go. So the first step was that weathering, right? And again, those people, tell me what you did again. And if you want to put this, never mind. We'll just go ahead and write it right here on our capture question. Sorry, I changed my mind there. Weathering people, what did they do? What did you do if you were a weathering person? Who weathered? Who was a weathering person? A lot of you were. Jody, what did you guys do? You ripped up the paper. Or in our pretend case, the rock, right? You ripped the paper or the rock. And then you handed it to the next people. We've said this a couple times. We're just trying to get it put in our brains. The next step was the runners, the erosion people. Yeah. And was there just one kind of erosion?
No, there were two.
I don't remember. Was there just one kind of weathering? I don't remember how it all worked.
The one person like ripped a big piece off or whatever.
One erosion kind? Okay, so there were different kinds of weathering, and we'll talk about that in a minute. I just couldn't remember how they divided up, because there are different kinds of weathering and different kinds of erosion, so I couldn't remember for sure. And the erosion person ran, or we'll say moved, the paper, also known as the rock. And at this point, what do you think that rock represented? Do you think it was big boulders at that point? What do you think it represented in terms of, this story? Sediment. Yeah, little pieces of sediment. And gave it to the third type of person was the deposition. And what did the deposition person do? Glued it down, right? Glued the sediment or the paper. I should have written that down the other way, sorry. Down onto the beach, right? There also was an earthquake. What was the earthquake? Was that part of the weathering, the erosion, or the deposition? Weathering. It was part of the weathering, yeah. Thank you for remembering that, Hannah. Thanks. We're going to talk about when we take our actual notes of that. We will definitely put that earthquake in. What was the result of the earthquake that was different from the other kinds of weathering? Do you remember?
Bigger piece of paper.
Bigger piece of You're like paper, rock, like, yeah, but it's a bigger chunk. You remember the pictures that we showed you after the earthquake in Alaska, right? Big pieces of rock breaking off. That's exactly what was happening. Absolutely. Absolutely. And how did you answer this question here? Could the beach have been created without your role? No. In order for this process to happen, all three of those, weathering, erosion, and deposition, all have to be present. If they're not, we can't have it. All right. Good so far? We're going to formalize it right here on this yellow piece of paper. So most of you have this one. Most of you even got it out already, which is fantastic. If you have not yet gotten it out, pull it out right now. I think everyone should have this piece of paper at this point. Does anybody need? Colin's like, not me. Oh my gosh, you guys.
Course list.
Where's the love, man? Seriously? Wow. All right. So, now that you all have your paper, here we go. Here we go. We are on a Thursday schedule. Just to make sure I keep track of what time it is. All right. We have written down, thank you so much, what weathering, erosion, and deposition are. We're going to write them down again. You can hold on to that because you're going to keep writing. Yeah. All right, here we go. So we're just going to write these down again. This is just some good notes. So weathering is a breakdown of the Earth's crust into sediment. Erosion is carrying away the broken down, or I'm going to say the sediment. Let's keep it simple here. Okay. From one place to another. And deposition is depositing, right? That's where deposition comes from, is depositing or settling of sediment. Into a new location. And then to be created into rock. What kind of rock, by the way? Yeah. Okay. There are some very specific details about these besides just the definitions that we want you to know, hence the chart, hence the weathering, erosion, and deposition columns. You ready to go? We talked a little bit. Oh my gosh, I forgot almost. Now you guys, we're going to pause for just a second. Will you go grab your marble chips? I want to know what they look like. I was going to look at them before school and I forgot. Somebody from each group, go get them real quick. I put the what do they look like? Are they still there? Can you grab them? Quick. Just pull them all down, then you guys can grab them. Hold them all down. Hold them all down. Thank you. She's like, oh, it's mine. Oh.
Ours didn't do anything.
It didn't at all? I don't think so. Feel it. Right? They're what, you say? They're gone!
Oh, wait, no. Okay, let's go for a second.
Open them up. Take them up. You don't have to take them back. Just take a look. Take a look right now. Report back.
Ours is right there, but there's a bunch of foam.
But it's kind of nasty, right?
It's very nasty. That is very nasty. Some people have like orange.
Take a look at them. Feel it though. Yeah. I don't think it feels like that. But does it feel kind of crumbly on the top? Like I feel like I got to feel it on my shoulder. All right. Scientists, I need your attention, please. I didn't intend for that to be so distracting, but more interesting about what you see. I want you to take a look at that rock. Do you see a change? Yeah. Maybe just by visually looking at it, you don't. But if you look carefully, do you see that it's kind of crumbly? No. Yes or no? Not at all? It's gross. Well, it wasn't gross before. Yeah, it's because it's broken down. Yeah, because it's different conditions, right? This one is evaporated more. That one has. But yeah, it's broken down. It's interesting. All right, my friends. What is that an example of? That gross. Ew, it's so nasty. I guarantee that even if you say it doesn't look different or it still looks like a rock, does it look the same as when you put it in the first time? Absolutely, it does not. Is this an example of weathering, erosion, or deposition? Weathering. There are two different kinds of weathering. We talked about them, right? We talked about changes of two different kinds. Remember, we had that chalk and went boom, 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 boom. And then we put some acid on it, and what did it do? What were those two kinds? Do you remember? Physical and chemical. That's what's going to go in your weathering column. We're gonna write a bunch of stuff, so make sure you've got space for it. So we're going to have physical weathering. I'm going to make a little line. And we'll do chemical weathering. Yep. Physical weathering, we've got, generally it's called abrasion. I-O-N, sorry, abrasion, okay? And abrasion, it just means breaking apart. Okay, and that's generally due to water. Drip after drip after drip after drip of water can help things to break down. Absolutely. What else do you think can cause abrasion? It's just a physical change, just breaking it down into pieces. Anything else? This is your weathering. What else were you guys besides water?
Snow.
Snow, yeah. So water or ice, we could say. Or snow. What else can cause rocks to break away? Physical weathering. What else did you say? An earthquake. I'm going to put earthquake down a little bit lower because we're going to talk about that in just a second. But we're just talking about, like, I guess, yeah, in my definition, breaking apart, yes, an earthquake would be an example of that. There's one more that I haven't thought about yet, or you guys haven't said yet. Did you have something, Jack?
No, I forgot.
Anybody out shoveling snow this week? Anybody have the opportunity to do that at your house? Yeah? Yeah? The snow did not all stay in one spot, did it?
When?
Yeah. The wind caused the snow to break apart and to blow, right? It caused it to break apart. That's another thing that we can talk about, causing physical weathering. Earthquakes absolutely can cause abrasion, as you said. And the other big one that I want to put out there, and this one is kind of funny to think about, but temperature change can also do that. We see that in Iowa a lot. I don't know if you've traveled a lot, but if you have, and if you've ever driven down south, you may notice that there is not nearly as much road construction that has to happen in the southern part of the United States as there is in the northern part of the United States, like in Iowa. Do you know why there is always road construction on the interstate? Probably because of the temperature change. There's something about the temperature change. What does temperature change cause our roads to do? Do you know?
So they crack.
They crack. They crack because water gets in the cracks. And what does water do when it freezes? It expands. And so you get the water down in the crack and it expands. And when it expands, it is strong. And when it is strong, it can break rock very, very easily. You with me there? Okay. It's called ice wedging. Okay. Those are your physical weathering types, the big ones. Physical weathering just changes the size or the appearance of rock, right? What does chemical weathering do? It changes the makeup of the rock, okay? That is what happened to your marble chip, okay? Your marble chip has now broken down. It's in smaller crystals. Some of it has changed color. And remember, color change was one of the indicators of a chemical change. You remember that? We took those notes earlier? Yeah. There are two big types of chemical weathering that I want to talk about. The first one you've probably heard of is acid rain. Okay. We're going to talk about where the acid in acid rain comes from later, I guess next week. Okay. But acid rain is caused by extra chemicals being brought up into those clouds and falling down with the water, right? And as you know, acid breaks down rock, right? We just saw that. Your acetic acid, friends, acetic acid is just what? Vinegar. Vinegar broke down that rock when given enough time, right? And vinegar is a pretty weak acid. So think about that. Acid rain does the exact same thing. It's water and chemicals that dissolve the rock. Okay. Water and chemicals that literally dissolve the rock. It changes the type of rock that it is. The other big example of a chemical change is what we call oxidation. You ever heard of oxidation before? Oxidation is a process when oxygen combines with iron. And what happens when iron is left out to weather? When it rusts. And if you've ever seen rust, like on a car, right? If you've ever had the opportunity to enjoy a car that has spent many, many, many winters in Iowa, right? The oxygen in the air combines with the iron that has been exposed, and it eats away at that metal, doesn't it? Like literally eats holes in that metal. That is a chemical change that occurs in that material. Yeah. That weathers that type of rock. Okay. Two big examples of weathering. Erosion can't occur without weathering. Erosion is not going to move huge mountains, huge boulders generally, down from one place to another. So erosion must happen after weathering, or we can say that weathering leads to erosion. Okay. We can also say that weathering breaks rock into sediment. and sediments are moved during erosion. Okay. What kind of things can cause erosion? What causes erosion? People running back and forth? What causes erosion? What in nature makes it happen? Wind. What else? So wind can move sediment. What kind of sediment is wind going to move? Big stuff or small stuff? Really tiny stuff, right? Wind is going to move very small sediment. Is that the only way that erosion happens? What'd you say? Absolutely water. Absolutely water. Okay. If there are pieces of rock that fall off into a lake or excuse me, into a stream or into a river, they can get carried down, can't they? Yeah, absolutely. Or with rainwater. We think of erosion a lot of times, prior to this conversation, we might think of it in terms of like topsoil erosion, right? You may have heard about that before with farming fields, which is why you have to plant farming fields a certain way. Okay, water absolutely can carry stuff away as it washes things away, okay? This can move small stuff, but it can also move larger sediments, we'll say, as well. Anything else that you know that might also carry sediment? It's a form of water. Ice. It's weird to think about. And it's not something that most of you have probably experienced unless you are a world traveler and you've happened to see very, very large sheets of ice, also known as, what are they called? Glaciers. Yeah. Glaciers can move large boulders even. Okay. During the warm temperatures, okay, glaciers retreat. So they get smaller, 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 and they can leave behind sediment. Probably should have said that 1 second. Sorry, I wasn't really thinking about the order there. And during cold temps, glaciers grow. And it picks up rocks and boulders. Write that more carefully here, sorry. Maybe, there we go. So these probably should have been written in the opposite order. I apologize for that. So in the winter, in the cold temperatures, when it's cold, cold, cold up in the Arctic, glaciers are going to get bigger, bigger, bigger. Does that make sense, right? Ice is going to collect on them. And with that ice, if there's something else underneath it or near it, it might pick up like a boulder. And we're talking like big stuff now, okay? The glaciers are going to grow. They're going to pick up rocks. They're going to pick up boulders, all of that sort of thing. And then as they retreat, as they melt, that boulder that may have been shifted just a little tiny bit is then able to move, okay? It leaves behind that sediment. And in that way, things can be moved a lot. Now, we think about that now. Where would you go to see glaciers these days? Any ideas? What's that? What'd you say, Hayden? The Arctic, absolutely. Like if I was going to go see a glacier, where closest place that I can see one, where would I go? What'd you say? I still couldn't hear you, darling. There are people talking. Greenland, absolutely. I could see them in Greenland. Where else could I go?
Canada.
I could go to Canada. What's that? Did you say something else
I
also?
was making fun of me.
Oh. Oh, that's not very kind.
That's Canada.
Kindness, yo. What else you got? Can you see them in the United States anywhere? In Alaska, for sure. Yeah. All over Russia. Now, have glaciers always only existed that far north?
I say nay.
No. In fact, we were covered by glaciers, okay? We were glaciated, which is why so much of Iowa is flat, okay? And a lot of the boulders, like if you're out like hiking, I mean, some boulders have been placed places, right? But a lot of boulders, like in natural areas, were brought here by, anybody? Indeed. Yeah, that's some big erosion happening, right? So some weathering happened to break that thing off of a mountain. The glacier brought it down, set it down, and oh my gosh, now we have what? Deposition! For sure. So the sediments are deposited through deposition, okay? It's not a lot to write down about deposition, but I do want to make sure that we have a moment to talk about it. Okay, so deposition means that the sediment has come to a place where it is not going to move easily, not going to move readily anymore. Okay, so the sediment is resting at a semi-permanent, I'll say, location. And through what that sediment can then turn into sedimentary rock.
Compaction and cementation.
Woo! Compaction means a whole lot of pressure. Stuff on stuff on stuff on stuff on stuff. Squish. Cementation means that you've got some chemicals in there that literally are gluing that sediment together, okay? Pushing it together, okay? Compaction cementation creates sedimentary rock. How are we doing? Okay? All right, so I've got a little video to show you to kind of help reinforce this, and then I'm going to introduce a quick project to you that you will be working on tomorrow, okay? So if you want to leave your notes out so you can write some stuff down as this video is going, I would strongly encourage you to do that. I definitely need you to pay attention, okay? And if you have a rock chip or some semblance of it, if you can set it over there by that sink, that would be very helpful for me.
Wow.
Good night.
Fair warning, not my favorite video ever. I didn't find it, but trying to, in the interest of keeping everyone together. All right, my friends.
We're about to get crushed, but it's okay. Are you guys gonna shop everything's ready to go?
Nice.
Probably not.
All right. Shh. For better or worse, I am confident that in the last 48 hours, you probably watched something worse.
No.
Because I'm sure, I don't know. Because you only watch quality stuff? Is that what you're saying,
I
Jacob?
didn't watch anything.
All right. So Here's your job. To watch it, to take it in. It may be the most exciting or least exciting 3 minutes of your day, but whatever it is, take it in, all right? Here we go.
Come on, let's play one more time.
Oh, I really can't. I've got to study for that weathering and erosion quiz tomorrow.
Zoe, playing Super Duo Breaker and Whoosh is just like studying weathering and erosion.
Somehow I think my teacher might disagree.
No. Check it out. In the game, Breaker and Whoosh are a superhero duo. They work together and change the land. Breaker breaks things down, and Whoosh carries them away.
And what does that have to do with studying?
Weathering and erosion work together just like Breaker and Whoosh. They're a scientific super duo. Weathering is the breakdown of materials in the Earth's crust into sediment. If weathering were a superhero, it would be Breaker.
Actually, that sort of makes sense.
Erosion is when weathered rock is carried away by gravity, water, wind, and ice. If erosion were a superhero, it would be Whoosh.
You're right. Weathering and erosion work together and change the Earth, just like a pair of superheroes.
Right. Think of weathering as a superhero that acts in different ways and breaks things down. It breaks down rocks with water. It wears things away with wind. It can even scorch or freeze the Earth with temperature, cracking and breaking it apart. When weathering acts like this, it's called physical weathering.
Wow.
That's only the beginning. There's another whole side to weathering's personality. Chemicals in the air mix with water to make acid rain that eats away at limestone rocks. Oxygen reacts with iron and forms rust. That's chemical weathering.
Then, after weathering is done breaking things down, his trusty sidekick, Erosion, steps in.
Yeah, erosion swoops in and picks up the pieces, carrying them away. Erosion knows how to move, and it does it all sorts of ways. It's the flow of water that moves rocks and sand, the push of the wind that carries sediment away, even the movement of a glacier dropping pieces of rock at the bottoms of oceans and lakes.
Glaciers move?
Yeah, glaciers are giant moving rivers of ice. They carry along pieces of rock and then drop them as they move. It's called deposition because the glacier is making a deposit.
Weathering and erosion really are like a super duo. Who knew?
You knew. You just needed to stop playing all those video games and think.
Oh, look who's talking.
So, you want to play another game?
Let's see if I've got this weathering and erosion song and dance down first. Weathering and erosion work together and change the environment. Weathering breaks things down and can be physical or chemical. Erosion actually moves the sediment that weathering leaves behind. Together, they're constantly changing our environment.
Looks like someone just got all their studying done.
Thanks to your help.
We're a pretty super duo ourselves.
There you go. Pretty awesome, right? That was, for whatever it's worth. All right. I have got 4 minutes, and in those 4 minutes, I'm going to introduce a project to you that I need you to listen very carefully because I don't want you to tell me you don't know this tomorrow or on Monday, okay? This project will be due for presentation on Monday regardless of what happens tomorrow. Let me repeat that. This project will be due for presentation on Monday regardless of whether or not we have school tomorrow. Don't look at me like that because there is a decent chance because it's going to be cold. It's going to be really cold. So, no. Listen, guys. If you keep talking, I'm not going to have time to explain it to you, and it will still be due on Monday. So let me make this clear. I am not saying we will or will not have school tomorrow. What I am saying is, regardless of whether we do or not, this will be due on Monday. Do you understand? Yes, Ms. Conning, that makes great sense. Awesome. So, if we have school, then you will have the 50 minutes that we have in class to work. If we don't have school, you still need to take that time during your day sometime tomorrow to work on it. Do you understand? Yes? Give me a thumbs up. I want to see everybody's thumb up so that I know that you understand me. If you don't understand it, Hannah, please put your phone away. Like, seriously. It is not, because obviously you weren't listening.
Project's done by Monday. Thumbs up.
Has to be done. All right, take a look at that purple sheet. I need you to listen. You need to understand how this is going to work. All right, so there are lots and lots of monuments, things that exist around our world that are weathering away, okay, that are being destroyed by the environment that they are in. So there is a big set of them here, okay? If we are here tomorrow in school, then you will be selecting them, and we may select them till today. I don't know for sure. But anyway, you're going to pick one, okay? On Canvas, there will be, it's not yet, I have the thing that I should not put the link up. There will be a link to Google Slides. You will put together a slide about your monument. Do you understand? Let me finish the whole thing and then I'll answer your question, okay? So the Google slide needs to have these 5 things on it. There's a template. So there's a place that says put the name. There's a place that says put a picture. Right, you with me there? So you're just going to fill in the pieces, okay? And then there's a second slide for your citations. You need to have at least 3 citations for me, okay? In addition, there will also be a link on Canvas for you to write down one multiple choice question about your monument. It must be, and it says it more clearly on your sheet than it does on this one up here because this one's older. It must be something that is answerable from the slide. Okay? Listen carefully, please. Those 2 things need to be done, again, regardless of whether we have school tomorrow. You may work with one partner if you would like, or you may work by yourself. Okay? I'll see you hopefully tomorrow.